Hello everyone. Today we are going to learn about historical development of computers. The historical development of computers can be better understood if we analyze history in terms of the time period as mechanical era and electronical era. A system that computes or calculates is simply called as computer. A modern computer system that we are using daily for different purposes came through a lot of revolutions. I have included only a few topics in each era so that we don't deviate much from the scope of our course. Let us first go through mechanical era. Abacus. It is difficult to imagine counting without numbers, but there was a time when written numbers didn't exist. The earliest counting device was the human hand and its fingers, capable of counting up to 10 things. Toes were also used to count in tropical cultures. Then, as even larger quantities, greater than 10 fingers and toes could represent, were counted. Various natural items like pebbles, seashells, and twigs were used to help keep count. Various portable counting devices were invented to keep tallies. The abacus is one of many counting devices invented to help count large numbers. When the Hindu-Arabic number system came into use, abacus were adapted to use place value counting. Abacus evolved into electromechanical calculators, pocket slide rules, electronic calculators, and now abstract representation of calculators or simulations on smartphones. Logarithm. The Scottish mathematician John Napier published his discovery of logarithms in 1614. His purpose was to assist in the multiplication of quantities that were then called signs. The whole sign was the value of the side of a right angled triangle with a large hypotenuse. Logarithms were meant to simplify calculations, especially multiplication, such as those needed in astronomy. He also created a manually operated calculating device called Napier-Bone for calculation of products and quotient of numbers. The board's left edge is divided into 9 squares, holding the numbers 1 to 9. A rod's face is marked with 9 squares. Each square except the top is divided into two halves by a diagonal line from the bottom left corner to the top right. The square contains a simple multiplication table. The first holds a single digit which Napier called the single. These 8 to 5 are called singles. The other holds the multiples of the single, namely twice the single, 3 times the single, and so on up to the ninth square containing 9 times the number in the top square. Single digit numbers are written in the bottom right triangle, leaving the other triangle blank or 0, while double digit numbers are written with a digit on either side of the diagonal. Here, 2 times 2 is 4. 2 times 2 is 4. 4 is placed on the bottom right triangle, leaving the other triangle blank or 0, because 0, 4 and 4 are same in terms of our calculation. Thus, we start filling these triangles from bottom to top. Let's see the product of 6 and 825. Our calculation should result in 4950. Let us see. 6 times 5 is equal to 30. So we have 0 on the lower and 3 on the upper right triangle. 6 times 2 is 12. We have 2 on the lower and 1 on the upper right triangle. 6 times 8 is 48. We have 8 on the lower and 4 on the upper right triangle. Now we can calculate the final product. We start with the last digit, which is 0 in our case. Then we add two adjacent numbers of our last digit, 2 and 3. 2 plus 3 equals 5. Finally, the result is obtained by placing the sum of adjacent numbers and the last digit, which equals 50 or 50. 50, then 50. We repeat the same process for all other rods. Now the adjacent numbers are 1 and 8, which sums up to 9. Thus, our new result is obtained by placing the sum of adjacent number, which is 9, and the previous result, which is 50. Hence, the result is 950. On the final rod, the adjacent number is 4. Since there is no another digit, we don't need to calculate the sum. What we do instead is we put this 4 in front of the previous result, which is 950. Hence, the result is 4950, which is the required answer. Pascal's machine or Pascaline. Pascal's calculator is a mechanical calculator invented by Blaise Pascal in the mid 17th century. Pascal was led to develop a calculator by the laborious arithmetical calculations required by his father's work as the supervisor of taxes in Rouen. The purpose of this machine was adding and subtracting two numbers directly and to perform multiplication and division through repeated addition or subtraction. Difference engine. The difference engine was an early computing device designed and built by Charles Babbage. Its primary purpose was to calculate and print mathematical tables, an expensive and error-prone procedure to do manually. The analytical engine incorporated an arithmetic logic unit, control flow in the form of conditional branching and loops, and integrated memory, making it the first design for a general purpose computer that could be described in modern terms as Turing complete. Babbage was never able to complete construction of his machines due to conflicts with his chief engineer and inadequate funding. Punch card. Punch cards date back to the late 18th and early 19th century when they were used to program cloth making machinery and looms. In the 1880s and 1890s, Hermann Hollerith used them with his tabulators, a core product of what would eventually become IBM. Lots of revolutions in mechanical era leads us to electronical era, where the emphasis was turned from mechanical parts to electronical parts. As a result, modern computers were built. ENIAC, which meant Electronic Numerical Integrator and Computer, was a computer built between 1943 and 1946. The machine was built out of nearly 17,500 vacuum tubes, 7,200 diodes, and many miles of wire. Because the computer was built out of vacuum tubes, it often broke. This meant that someone had to find the failed tube, which was not an easy job, take the bad tube out, and put a working tube in. Making programs for the computer was difficult. Making the computers ready for one single program could take many days or even weeks. This was because the programming had to be done by pulling wires from one place to another. This was not hard for small programs, but if a large program was wanted, it was very hard work. Programming by pulling wires was used until 1948, when a special type of memory was added called read-only memory or ROM, because the computer could read it but not write it. After that, the programming was done by using switches, which only took hours instead of days. UNIVAC, the Universal Automatic Computer. It was the first computer built for general commercial use and used magnetic tape rather than punch cards to input and store data. UNIVAC speed outshined all of its competitors. It was thousands of times faster than its rivals, but more importantly, it was among the first stored program computers using magnetic tape rather than the punch cards to collect and manage data. Up to 1 million characters could be stored and accessed on magnetic tape. An operator did not have to load data into the machine every time he or she wished to perform a calculation. Instead, the UNIVAC could access data stored on its magnetic tape. Apple first. The Apple Computer 1, originally released as the Apple Computer and known later as the Apple First, is a desktop computer released by the Apple Computer Company. now Apple Incorporation, in 1976. It was designed by Steve Wozniak. The idea of selling the computer came from the Wozniak friends and co-founder Steve Jobs. The Apple I's built-in for a computer terminal circuitry was distinctive. All one needed was a keyboard and a television set. The Apple One did not come with a case. It was either used as is or some choose to build custom, mostly wooden cases. Production of Apple First was discontinued on September 13, 1977, after the June 10, 1977 introduction of its successor, the Apple II. Macintosh, mainly Mac, since 1998, is a family of personal computers designed, manufactured, and sold by Apple Incorporation since January 1984. The original Macintosh is the first successful mass market all in one desktop personal computer to have featured a graphical user interface, built in screen, and a mouse. Thank you for watching. We will continue our lecture in our next section.